All right, let's go ahead and check out and see what's happening here. So we have a table set up for you with some times, and as you can see with the times, an hour is passing in between each one of them. It says that it opens at 10 o'clock, so that will be our 0 hour. So I do want to make sure we're clear here that this is your 0 hour, but it actually is 10 o'clock, so we may have to do some finagling at the end. We always start off with $100. So that is our, nothing has happened to it yet, that's just kind of our initial value, that's where we're all beginning. And then each hour, the amount of money in the register increases by 10%. Well, the first thing we have to do is figure out what 10% of 100 is. I hope that you know what that is, but if not, 10% is not usable as a percent, but if you write it as a decimal, you can. And when you're talking about percents of things, you would want, it's always percent of, so it's always multiply, and so you would always say 100 times 0.1. And that would be 10% of it. Now, here's the deal. This is dollars in the drawer. How much is actually in the register at each hour. So in an hour, 10 more dollars goes into it, but that would put us at $10. Now, here's the deal. Then we're going to increase this by 10%. Not by $10, but by 10%. So if you do that amount times 10%, you actually get $11. So we're actually going to be increasing by $11 here, which will give you $121. And then we want to increase 10% of this one here. So we do 121 times 0.1, which is $12.10. So now we're starting to get into pennies and not just dollars. And then we want 10% of this at 133.1 times 10%, which gives us $13.31. We add that to the total in the drawer, and we continue. Actually, we just want to have actual money, so we'll go ahead and say that. So that's what our money is. Now, assuming this is a geometric sequence, what is the multiplier? Now, this is tougher because the reality is that we need to figure out what times this equals this. And it's not like it's 2 and 6, where it's, oh, it's times 3. So in this case, if you aren't sure of what to do, you could always just say 100 times some value x is equal to what we're looking for, and we're trying to figure out what is the multiplier. That is the power of algebra. So you can set up a little equation and go for there. Now, if I needed to get x by itself, I would divide by 100. So I'm going to take $110 divided by $100, and I get 1.1. Now, we want to just check and see if that really is going to work. So if I take the 110 times 1.1, just kidding, I need a point in there. There we go. Sure enough, I get 121. So it looks like we have found a multiplier that will work over and over again. So this is exponential. This is our geometric. So we take our $100 of our initial value times the multiplier to the nth power. Now, here's the tricky part. It says if it closes at midnight. Now remember, we're not wanting to know the 12th hour or the 12th term. We want to know which term number is 12 o'clock. So I just need to find a pattern here because I don't want to have to go all the way out to 12 o'clock. So if I notice here, this is what? 2 more than, 2 more than, 2 more than. Oh, tricky. So it looks like this would be like 14. Now let's just double check and make sure that that's right. So 5 would give us 7, 5, 6, 7, 8, 9, 10, 11, 12. So that would be the 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th term. So sure enough, that is the 14th term, and we want to know how much will be in the register at that time. So again, you notice I'm trying to find a pattern, and I'm not real sure, is that really going to work? I can always just kind of check it real quick here. So how much is in the register? That means that we would plug in, this is the power of the rule. I don't have to actually complete the table all the way out there. I just need to plug in 14. So on your calculator, to plug that in, you would take 100 times, 1.1. Now this little caret button right here, this gives it any power you want. So I want to plug in 14, so I can plug it in that way. Some of you have other buttons, and just ask me if you need some help on that. We can help you out. So at the end, we would have $379.75. Now, to detract from robbers, the Quickie Mart had decided to empty the register as soon as it contains 250. What time should this happen? So at this point, we really just need to kind of fill out our chart. We know it's closer to the sixth term than it is to the other. So I'm going to go ahead and just say, now here's the power of the graphing calculator. If you have a graphing calculator, you can plug in the equation. This is awesome. So we do 100 times 1.1. And if you have a phone, you can use this as well. But you just need to plug in the rule. And then we can look at the graph just for the sheer fun of looking at the graph. I need to change my zoom though so it fits. Let's take a moment and do that. So go to zoom and go to the zoom fit. Let's try that one. I'm looking at these little guys moving up here. Yeah, here we go. So here is our little exponential. Now it almost looks linear until you put something that is linear next to it, and you can see it's definitely a nice little curve there. So that was the graph, but the reason why I did this actually was for the table. And most of your phones have this value as well. So I can now kind of go down in here until right here. So this is 259 and this is 235. So between the 9 and 10 time, we want to go ahead and register. So what we want to do is say, so that's, I'm sorry, that's the 9 and 10 term number. But remember the, this was, oh no, I'm sorry. These were the times I wrote up here, 4, 5, 6, 7, 8, 9. So this was 6, 7, 8, 9, 10. So between the 9 and the 10 term number is between 7 and 8. And you could start plugging in different values of 7 to get closer and closer to 250.